Okay, today we're going to be learning about completing the square. And these are the content standards and the mathematical practice we'll use when we are working the assignment. Previously, you factored perfect square trinomials. Now you're going to solve quadratic equations by using the square root property and by completing the square. One new vocabulary word today, completing the square. You have solved equations like x squared minus 25 equals 0 by factoring. You have also used the square root property to solve such equations. Now we're going to find the solutions to equations with rational roots by using the square root property. So this is our original equation. Notice that this is a perfect square. So x plus 7 squared is equal to 64. We take the square root of both sides. So here we have both roots of a square root of 64. So x plus 7 could equal a positive or a negative 8, since the square root of 64 is 8. So now we're going to subtract 7 from both sides to solve for x. So x is equal to negative 7 plus 8, or it could be negative 7 minus 8, because it was plus or minus 8, remember? So it could be x equal to 1 or x is equal to negative 15. So the solution set is negative 15, 1. To check it, we're going to substitute both values into the original equation. And we end up with 64 is equal to 64 on both sides. Excellent. Why don't you check your progress? Solve this trinomial by using the square root property. Okay, answer is C. So this one factors into x minus 8 squared, the quantity squared, is equal to plus or minus the square root of 25. So x minus 8 is equal to plus or minus 5. When we set x is equal to 8 plus 5 and x is equal to 8 minus 5, we get 3 and 13. Now, roots that are irrational numbers may be written as exact answers in radical form or as approximate answers in decimal form when a calculator is used. So in other words, if you get square root of 34, you can either leave it square root of 34 or you can enter it in your calculator to find out what the decimal approximation would be. Okay, we're going to solve x squared minus 4x plus 4 is equal to 13 by using the square root property. Here we're going to end up with irrational roots. Let's see what that means. This is a perfect square trinomial. X minus 2 squared is equal to 13. We take the square root of both sides. Don't forget your plus or minus. We're going to add 2 to both sides. So we end up with x is equal to 2 plus or minus square root of 13. So x is equal to 2 plus the square root of 13, and x is equal to 2 minus the square root of 13. So if we use our calculator to find out what the square root of 13 is, we're going to find out that x is approximately equal to, that's what this little squiggles mean, 5.61, or x is approximately equal to negative 1.61. The exact solutions of this equation are left in radical form. The approximate solutions are 5.61 and negative 1.61. You can check these results by finding and graphing the related quadratic function. There's the related quadratic by subtracting 13 from both sides. And you can graph that, use the zero property, and you should get about the same zeros. Remember, the zeros, the roots, the solutions are all the words for the same meaning. We're finding where that graph crosses x. Right, time to check your progress. So pause for a moment and work the problem, then come back and check your answer. 2 plus or minus 2 times the square root of 2. So I ended up factoring this one. X minus 2, the quantity squared, is equal to 8. So x minus 2 is equal to plus or minus the square root of 8. The square root of 8 is approximately equal to 2.8, but I really didn't need that because we left this one in radical form. So we've got 2 plus 2 times the square root of 2, or 2 minus, or you could say 2 plus or minus 2 radical 2. Now for our second objective, completing the square. Now all quadratic equations can be solved using the square root property by manipulating the equation until one side is a perfect square. Now this method is called completing the square. So we'll look to see what these steps mean. We're to find the value of c that would make this a perfect square, and then we're to write the trinomial as a perfect square. So we take half, if this is written in standard form, a x squared plus bx plus c, we take b, divide it by 2, and then we square whatever answer it is. So 36 is the answer to c, what we need to be a perfect square trinomial. So let's look at that again. We take 12, divide it by 2, and then square it. So 12 divided by 2 is 6. 6 squared is 36. So the trinomial can be written x plus 6 squared. So looking at this one, what would c need to be for it to be a perfect square trinomial? And then write the trinomial as a perfect square. Okay, half of 6 is 3, and 3 squared is 9. So that perfect square would be x plus 3 squared. You can solve any quadratic equation by completing the square because you are solving an equation. So we're going to add the value used to complete the square to each side, noting that you can only use this method when the coefficient of the quadratic is 1. So whatever is with the x squared, it has to be a 1x squared. You can't have an 8x squared or a 5x squared. It has to be a coefficient of 1 in order to complete the square. If it's not a coefficient of 1, you have to divide by whatever's with the quadratic in order to solve it. Okay, so notice that x squared plus 4x minus 12 is not a perfect square. So we're going to add 12 to both sides. Okay, then we're going to take half of 4, which is 2, and 2 squared is 4, and we're going to add it to both sides. Because if we add the same number to both sides, it keeps it equal. Whatever we do to one side, we do the other, it keeps it equal. So we can rewrite this left side as x plus 2 squared, and 12 plus 4 is 16. So again, take b, take half of it, 4 divided by 2. 4 divided by 2 is 2, 2 squared is 4. So x plus 2 is equal to plus or minus 4. We're going to subtract 2 from both sides so that we have x is equal to negative 2 plus 4, or x is equal to negative 2 minus 4. So x could be, our solutions 2 and negative 6. So the solution set is negative 6, 2. So time to check your progress. So pause for a moment and work this one, and then come back and check your answer. Okay, our answer is going to be B. Notice that 8 is not a perfect square, so we're going to subtract 8 from both sides. Half of 6 is 3. 3 squared is 9, so we're going to add 9 to both sides. So we're going to end up on this side, x plus 3 squared. X plus 3 quantity squared is equal to 1. So x plus 3 is equal to positive or negative 1. So when we solve, we get a negative 4 or a negative 2. Now when the coefficient of the quadratic term is not 1, so notice we have a 3 here, you must divide the equation by that coefficient before completing the square. Okay. So this one's not a coefficient of 1, so we have to divide every term by 3. We don't have, this one's not a perfect square, so we're going to add 1/3 to one side. You're going to take half of 2/3, so a negative 2/3 times 1/2. You're going to end up with a negative 2 over 6, which is a negative 1/3. We're going to square it. That's going to make 1/9. So we're going to add 1/9 to each side. So we can rewrite it x minus 1/3 quantity squared is equal to 4/9. Okay, now we're going to take the square root of both sides. So square root of 4 is 2, square root of 9 is 3. So it's plus or minus 2/3. We add 1/3 to both sides. So it's either going to be, our solutions are 1/3 plus 2/3 or 1/3 minus 2/3. So our solution set is negative 1/3 and 1. You can check this by putting it back in the original equation. Okay, time for you to check your progress. So pause for a moment, work the problem, then come back and check your answer. Well, first of all, we noticed the coefficient's not a 1, so we have to divide every term by 2. We're going to have x squared plus 11 halves x plus 5 halves equals 0. Or, 15 halves, I'm sorry. We're going to have to subtract 15 halves from both sides. We're going to take 11 halves, half of it, and that'll be 11/4, and then square it. We're going to have 121/16. Sorry about that, folks. Okay. We're going to have 121/16 that we're going to add to both sides. So we can write it as a perfect square. X plus 11/4 quantity squared is equal to 1/16. We take the square root of 1/16 as plus or minus 1/4. So we have x plus 11/4 is equal to plus or minus 1/4. So that's how we end up with 10/4, which reduces to 5 halves, or 12/4, which is a 3. Not all solutions of quadratic equations are real numbers, and in some cases, the solutions are complex numbers of the form a plus bi, where b is not equal to 0. So we're to solve this one by completing the square. We subtract 11 from both sides. Half of 4 is 2. 2 squared is 4, so we're going to add 4 to both sides. Rewrite it, x plus 2 quantity squared is equal to -7. So x plus 2 is equal to plus or minus the square root of -7. Notice we have a square root of a negative number, so we know that we're going to end up with a complex answer. X plus 2 is equal to plus or minus I times square root of 7, because square root of -1 is I. We're going to subtract 2 from both sides, so our solution set, -2 plus I square root of 7 and -2 minus I square root of 7. Okay, time to check your progress by completing the square, so pause for a moment and come back and check your answer. Answer is D. So I'm going to subtract 5 from both sides, add 4 to both sides, so I have x plus 2 quantity squared is equal to -1. I'm then going to subtract 2 from both sides, so -2 plus or minus I. So -2 plus I, -2 minus I. All right, you're ready to begin your assignment.